All right, so the first step, our radical is already isolated. So we're going to undo it by squaring both sides. When we square both sides, we get 2x plus 3. The left side, the radical and the power cancel. On the right side, this becomes a binomial square. So you use the same pattern that we have on the other. Okay, we square the first term. We add the product of these two bases doubled. So 4 times the negative root x minus 2 doubled gives you negative 8 root x minus 2. And then you square the last term, always going to be a plus, but x minus 2, the square root of x minus 2 is just x minus 2, okay, when you square it. Okay, so here's my new equation. I'm going to go ahead and isolate my radical because I still have a radical in this equation. So here I'm going to subtract an x from both sides, give me x. I'm going to add 2 and subtract 16, so a total of subtract 14 from both sides. When I subtract 14 here, I wind up with a total of minus 11. Okay, and then this negative 8 root x minus 2 stays as it is. Okay. Now, when I square both sides, I can either completely isolate my radical. If that's the case, I divide both sides by negative 8. I don't really want to work with fractions yet. So I'm going to leave the negative 8 right where it is. Okay, because when I undo my power, or undo the radical here and square it, okay, it's still gonna take into consideration the negative 8 squared, but it's not going to be in the fraction form yet. Okay, it just makes it simpler to work with. So I'm going to square my binomial over here. Same pattern, square the first term, x. Take the product of these terms and double it. X times a negative 11 doubled is negative 22x. Square the last term, 121. Here, square the negative 8 becomes a 64, and the radical and power cancel, leaving x minus 2. So here, notice that I can distribute my 64, giving me 64x minus 128. And then I can move everything to one side. I have multiple variables in my equation. Okay, so I'm going to move everything to one side and set it equal to 0. So my x squared stays. Subtract 64x from both sides. Add 128 to both sides. And that gives me my equation here. Okay, so the final step here would be to solve this. Again, you can solve it by any method that you have. These are relatively challenging numbers to work with, so you might look for some factors of 249. Okay, a couple things to look at when you're factoring larger numbers. So we know that this does not have a common factor of 2, right? But let's test, does it have a common factor of 3? If you add up the digits, 2 plus 4 is 6 plus 9 is 15. Is that total sum divisible by 3? Yeah, so that means that this is divisible by 3. So if we take a look, 3 goes into 24, 8 with none remaining. 3 goes into 9 3 times. So you have 83 times a 3 gives you 249. Since the product is positive, we know the signs have to be the same. Since the middle term's negative, we know those are going to be negatives. Okay, is it true that these two factors right here have a total sum of minus 86? Yeah, it turns out that that works. Okay, there wouldn't be any other combinations here that work. So if I rewrite my middle term as that sum, drop my first and last terms down, and factor by grouping, I can remove an x from my first pair of terms, leaving x minus 83. I can remove a negative 3 from my second pair of terms, leaving an x minus 83. Take out my common binomial factor, the remaining factors of x and minus 3. Form my other binomial. Again, this is all set equal to 0. And so I have my two solutions of 83 and 3. So I do want to go back in and plug those into my original form. So here, if I took the square root of 2 times 83 plus 3, does that equal 4 minus the square root of 83 minus 2? Well, looking at this, again, if I don't have to go through all of it yet, but 83 minus 2 is 81, so this is the square root of 81, which is 9. Can 4 minus 9 equal the square root of something? 4 minus 9 gives me a negative value, so I know that 83 is going to be extraneous. So now I'll test my 3. So 2 times 3 plus 3, is that equal to 4 minus 3 minus 2? So here I have 6 plus 3 is 9. The square root of 9 is 3. Does that equal 4 minus 3 minus 2 is 1? Yes. And so that one would work. Or if there's more than one radical, same idea. Go ahead and just enter the solve feature. Type in what you have. Square root of here 2x plus 3. Close that off. Set it equal to 4 minus, again, another square root. In this case, x minus 2. Close that off and then tell the calculator, comma x, you want it to solve for the x's. And again, when you do, you get your solution, which in this case is just 3.